Hello everyone. Our topic is radio frequency identification technology in smart supply chain. Reference systems transfer energy and data via radio risks, balancing economic and ecological sustainable development. Electromagnetic technologies advance industry, but bring in radiation hazard and e-waste pollution, which we will analyze thoroughly, combining academic papers and industry data. We will illustrate refills electromagnetic mechanism, advantages, drawbacks, and eco-friendly improvement measures. First one.
Now we will introduce the basic RFID system. It has three core parts: reader tag and antenna. The whole communication follows the four-step interrogation response process. The reader sends energy and timing signals to wake passive tag. Tags reflect stone ID data back via modulated carrier wave, and the reader decodes data for backend system. Energy, timing, and data transfer together enable non-contact automatic identification. This is near-field inductive coupling based on transfer magnetic induction. The reader's coins generate alternating magnetic field to power tag within 1 meter. It uses load modulation to transmit data, stable against mental interference, and is widely used in access control and NFC. Limited short reading range is its main feature. UHF RFID use far-field backcounter coupling, the teach we use for supply chains. Tags harvest RF wave energy and reflect signal by switching antenna impedance to send binary data. It supports long-distance multi-tag fast reading up to 10 meters. However, its reflected signal is vulnerable to metal and liquid interference.
Next, let's look at how RFID speeds up warehouse operations. Case studies of Tesla and JD show both contactless scanning replaces store manual barcode work. It cuts scanning time from hours to seconds, snatches number codes, and enables fully automated unmanned warehousing. Beyond speed, RFID realizes focus traceability. It updates real-time inventory data, locates items accurately on shelves, and supports full lifecycle tracking. Encrypted chips for Lucy Goods also deliver reliable anti-counterfeiting throughout the circulation. Here are quantitative improvements brought by RFID. Inventory accuracy rises to 93% to 99%. In-stock rate goes over 45%. Inventory turnover improves 20 to 30%. And overall, supply chain's performance leaves more than 36.3%, cutting waste and lifting profits.
Now we analyze RFID's electromagnetic radiation risk to human bodies. We adopt SAR as a safety elevation standard with clear ERP power thresholds for public and workplace scenarios. Commercial UHF readers only output 1 to 4 watt power. below safety limits. Simulation heat maps prove human electromagnetic absorption is extremely low, so RFID radiation is generally safe. However, disposable RFID tags brings several environmental burdens. First, plastic substrates cannot degrade and create microplastics. Second, cheap heavy metals cause soil and water contamination after the disposal. Besides, tech production generates considerable carbon emissions, forming long-term ecological pressure.
Tackle RFID's environmental issues, we propose three circular economy solutions. Firstly, switch to reusable industrial RFID tags. They support 100,000 rewrites and last 5 to 10 years, cutting tag waste by over 80%. Secondly, adopt green biodegradable labs made of PLA and paper annotations, which reduce plastic and microplastic pollution after disposal. Thirdly, build ISO 59040 closed-loop recycling systems with a 92% material recovery rate to form a full eco-cycle. We also add two complete treatment to improvement, define energies, green design duties, and expand electromagnetic reductions management to retire and daily life seriously.
That's all for our project. Thank you.